Hi, my name is Stewart Lynch. In this video, I'm going to be doing something different. Instead of teaching you a new concept, I'm going to be cycling back by using what I've taught over the last year, and in doing so, I'll be using two tools that I find extremely helpful. And the first app is called Ducky, and the second is a website called Mocaroo. Both of these tools can help you practice your craft and assist you in building the data models from an API and parse the data. Before I get started, I just want to ask that if you like what I'm doing, and this video in particular, please leave a comment and give the video a thumbs up. You can also subscribe to the channel to get notifications of new releases, and it really encourages me and helps me to grow the channel. So let's go. In the past year, I created a number of videos on fetching data from an API. It all started with my series on JSON parsing and the Codable protocol in Swift and SwiftUI. I followed that series later on in the year with a video on the result type, where I reworked a pretty standard function to fetch data from an API to use the new result type. I spent more time on the result type when I explained enums with associated values. I firmly believe that the only way you can really learn something and understand it is to practice with a number of different scenarios until it sinks in. And this is what this video is all about. I'm not going to show you how to use the Codable protocol because I have an entire series on that. I'm also not going to go into detail about the result type and enums with associated values because I have videos on those too. If you're not clear on those concepts, I'd recommend that you work through those videos. But even if you're not sure, it may be worth watching and working through this video so that you'll be able to get an understanding of where you might want to be in your coding progress. In this video, I'm going to use that getJSON function that I introduced in the Codable series and refined in the result and enum videos to practice building data models from an API request and then fetching the data from the API. We'll go through a number of different scenarios with the hope that by the end, you'll feel comfortable using the function in your own projects and understand how it functions, so to speak. I've created resources for this project that I want you to use, and you can download them from the link in the description below. The first is a simple text file that contains the function and the related enum error, and we'll look at that in a minute. And the second is a playground with 5 pages. The first is the introduction, and the other 4 pages we'll use to fetch and decode data from 4 different API endpoints. So let's get started. If you open the fetch.json.txt file in the text editor, you'll see that there is an enum called API error, along with a function named getJSON. Let me copy this to my clipboard so that I can get it into my playground. Let's create a new file in our playground in the global sources folder called APIService. And I'll paste the code into it so that we can view the code with syntax highlighting. As I mentioned in the introduction, I have some in-depth videos on the Codable protocol and parsing JSON, along with how the result type works, so I'm not going to spend a lot of time going over this function. We essentially build this function in the JSON Codable series. The function has 4 parameters, a URL string along with a date decoding and key decoding strategy, and both have preset defaults, so there is no need to pass these as arguments unless you want different values. The last parameter is an escaping trailing closure that is passed in by the call site, and its argument is a result type with the success case being generic and the failure an API error, which is also defined here with one case that is an error that has an associated value named error string. The function first checks to see if the URL is valid, and if not, the completion handler is called with the failure output being our API error, with the error's associated string being the invalid URL. If the URL is valid, a request is formed and passed to the URL session data task. If an error occurs here while trying to fetch the data, the completion handler is called with the result failure output again being the API error using the fetch error's localized description. Now if there's no error, it checks for valid data. And if the data is not valid, again it calls the completion handler with another failure and the API error. Finally, then we can proceed to decode the data using JSON decoder. The date decoding and key decoding strategies are set, and an attempt is made to decode the data using the generic type. If that fails, one more failed output to our completion handler. If we are successful, however, we can then use the results success output using our decoded data as the results success associated value. Now what I want to do is to use the API error and function in all of my projects or playground pages, and that's why I've put it here in the sources folder. But we need to do a couple of things first. I'm going to enclose both the enum and the function in an enum called APIService. And I use an enum here as a namespace so that if I want to access any static properties or functions, I can just use APIService dot to get code completion. I could have used a class or a struct or an enum here, but I like enums because there's no danger of creating an instance of it, because you can't. Now, we don't have any static properties or functions yet. We have one function, and we definitely want to use it, so we'll make it static. The API error will be accessible as well through the dot syntax on the API service if we need it. And we will, since the closure that we pass in needs to know what type our error or result expects. Now in your projects, if you only have a single module, you could use this file as is. For us, however, because we're in a playground, the sources folder is treated as a separate module, so we'll need to make the service itself and both the enum and the function public. So now we're ready to use it. A great place to start practicing is with JSON placeholder site. This site provides you with a number of different API endpoints that return JSON data. For example, these links will return JSON data here. And we're going to look at two of them now and see if we can build a model and then fetch the data and create arrays of our model with that data using our function. Let's look at ToDos first. If we click on this link, we see that the URL here produces an array of JSON data. And each of these objects within the array have 4 properties. And it's rather trivial to create a struct that will represent this data. So let's do that. We'll call it ToDo and make sure that it conforms to the Codable protocol. It has 4 properties, user ID and ID, which are both ints, title, which is a string, and completed, a bool. Now, if I want to fetch that data and then loop through and print out the titles and the completion status, I can use the API services getJSON function for that. Now notice that there are 2 overloads, one without the 2 strategies and one with. And since we're not using any dates, I'm going to choose this first one. The URL string is our endpoint. So I can copy it and paste that in here. Now if I hit enter on the completion, we see that what is required for our argument, and it's a result that must have an associated decodable success and API service API error failure. If we just enter result for our result argument, we are told that the generic parameter t can't be inferred, so we can't rely on type inference. We need to be specific by saying that the result is a result type, with the success case's associated value being an array of ToDo, and the failure case has an associated value of an APIService.API error. Now, since this result is a result, we can switch on it and deal with the failure or success since each one has the associated value. Let's deal with the failure first. We know that the failure has an associated value and it's an enum error, so let's just use let error. Now, there may in the future be more cases than that one that we have, so I'm going to use a switch statement on that error enum. And as it turns out, there is only one, and it too has an associated value. So let's call it error string. Having that, we can deal with it. And in this case, I'm just going to print it out. In reality, though, this call to the API service will likely be in another services file that itself will have a closure that the UI can deal with if there is an error. But for now, we're just going to print it out to our console. Now for the success case, we know that we get back an array of to-dos, so I'll call them to-dos, and I'll run a loop through them, and I'll just print out the title and completion status to the console. If I run this now, we see we get all 200 to-dos printed to the console, listing the gibberish to-do along with the completion status. That's about as simple as an API gets. So let's move on to one where the model is slightly more complicated. Still using the JSON placeholder API, let's take a look at the user's endpoint. This time the array is a bit more complex, as each array element consists of a user with many key value pairs, some of which are objects like the address that has multiple keys, and one of them is a geo which also has 2 key value pairs. The company is another key where the values are itself an object with 3 key value pairs. So this is going to require 3 models, one for the user, one for the address, and one for the company. Now it might be worth your while to work through this on your own, as I've done in my earlier videos, but I'm going to use a great tool, and it's called Ducky. And it's available for free on the Mac App Store, and it's also available for the iPhone and iPad as well. And I have another video that I'll reference in the description below, where I go into more detail than what I'm going to show here. Let me show you how useful it is. First, let me copy the JSON from the JSON placeholder site. And now I can paste in the JSON into this window, and Ducky does its work. Just like that, our model is created. On the right, you need to give your model a name, so I'll call mine user. And for the rest, I'm leaving it at the defaults, where the model type is a struct, and the protocol conformance is Codable. I'm also leaving it where the structure style is nested, as you see it here. So let me copy and paste that into our playground. Now, just because we have all these properties available to us from the API, it doesn't mean that we have to use them. So let's say we're not interested in the geolocation. So I can remove the struct and the property from the address struct. Now, I want to retrieve all 10 users and print out their username, the city where they live, and the company's catchphrase. So we're going to repeat the same process as the last example using our API services getJSON function, and we'll pass in that endpoint. For our closure argument, we'll call it result, and as the type can't be inferred, we'll need to specify that it's a result type and that the success case will be an array of users, and the failure can be an API service API error. Let's switch on result once again. And knowing that there is a success and failure type for result, the switch knows that both cases have an associated value. So we see that success is an array of user, so let's call it users. Similarly, for the failure case, we see that it's going to be an API service API error, so we'll call it error again. Now for the failure, it'll be the same as the last one, so let me just go to that previous example, copy that same code, and paste it in here. For success, again, it's an array of users, so we'll loop through them. And let me use a multi-line string and string interpolation this time. On the first line, I'll print out the username. On the following line, I can print out the user's address.city. And on the last line, I'll print the user company catchphrase. Running this, now we see our results. For more clarity though, let me just add some spaces before the city and the catchphrase. That's better. we see all 10 of our users. For this example, I'm going to build my own API, and to do that I'm going to use this wonderful site called Mocaroo.com. This site allows me to create our own JSON for testing, so you can mock up your models. And this is done through a schema. And you can specify the field names and type of information that you want to retrieve as your dummy data. For example, if we add a new field and then go to the type field, we can choose from 143 different categories. For example, if I go to personal, it can generate URLs for random avatars, first and last names, genders, and language, etc. And you can explore this on your own. Once you've built your schema, you can specify how many rows you want and the format, such as JSON, and make sure you always specify arrays. You can choose if you want to include some null values. Let me delete that incomplete field first and show you what the JSON looks like. You can create your own schemas, and if you have an account, which won't cost you anything by the way, you can save your schema and create an API. When you save your schema, you'll see that listed on the Schemas tab. You see I have one here. And you can see that by tapping on this link. If I preview the JSON, you'll see that I have an address key that has an object as a value. And the siblings key is an array of objects. By using dot notation here, we can create nested objects like this, one here for address, and siblings as an array of objects. Now here's the really cool part. You can create an API. When the API is created, you can click on the link to get the full API information. But in particular, it is this link here, which is the endpoint URL, and that's what we want. And that's the link that I've entered here in the playground. So let's do that. First, let me copy that URL and paste it into the browser so I can get the JSON. Now, let's use Ducky to generate the model for us. I'm going to call the model family. I'll leave the defaults as before, and I'll just copy the struct now and paste it into my playground. There is something that I want to change, however. I see that both of the birth date properties have been designated as strings, and I want to change them to date types because that is what I've specified them as in Mocaroo. And now let's follow that same process as we've done already using our APIService.getJSON function. I can use our API endpoint as our URL string. For the argument, which I'll call result, I need to specify the type as a result, with the success associated value being an array of family, and the failure case an API service API error. The next step, as always, is to switch on the result with the success and failure cases. For our failure case, we'll do the same thing and print out the error. So once again, I'll copy from the previous example and paste it in here. For the success case, let's print out the family last name and then loop through all siblings. And within the loop, we'll print out their first name followed by their birth date. Let's run this. This time I get an error. Error decoding data, and that is resulting from the getJSON function and this completion here. Well, why? Let's check out the Mocaroo API. And I see that they are dates, but unfortunately, that's not the default date decoding strategy that our API service is expecting. In this case, we need to specify a date decoding strategy. So just before the call to the API service getJSON function, we need to create a DateFormatter. Now I have a video on DateFormatter, so I'll leave a link in the notes below. So we'll specify a date format, and that format is the string YYYY-MM-DD. Since the default date decoding strategy in our getJSON function is the wrong one, we'll need to add that argument to our call. So the date decoding strategy is the JSON decoder date decoding strategy, which is an enum, and we'll choose .formatted that has an associated value, which is that date formatter that we just defined. And while we're at it, we should print out our date using the format in our print statement using the DateFormatter string from method, passing in the sibling birth date. Running this playground now, we get our family member along with all of his or her siblings along with their birth dates. I encourage you to use this playground to explore more APIs and use Ducky and perhaps Mocaroo to build your own API test. But I have a challenge for you. For the challenge, I'm going to ask you to try to retrieve data from the iTunes Store's Web Service API. And you can check out the documentation here. I don't want to get into the details, but by reading through the documentation, you can request information on what is available in the iTunes Store. For example, I've determined that this URL endpoint will retrieve all of the albums by the Beatles. I'm going to paste this JSON into a JSON formatter so that I can take a look at the JSON structure. Now the challenge is to use the APIService getJSON function to print out a list of all of the albums and include the track name and release date. But there are a couple of gotchas here, so take your time. Some things to note. The JSON retrieved is not an array of objects this time. It's a single object with a key whose value is an array of objects that will be your albums. The first object is not the same as the remaining ones. So as a result, most of your model properties will have to be optional, and Ducky can take care of that for you. If you use Ducky, it will, at least for me, make a mistake. It interprets the collection ID as a date instead of an int. It does interpret the optional release date as a date okay, but you should use the nsdateformatter.com site to find the right date formatter that you can pass as the date decoding strategy. I think it's this one. So pause the video now and give it a try, then resume to see how I solved the problem. So here's my solution. So here's the model that Ducky generated for me with the modifications that I referred to. I called my struct band. I changed collection ID to an int, and the results are actually the array of albums produced by the band. I checked out the JSON format for the dates and used the nsdateformatter site to figure out that the date formatter is this one here, and that allowed me to create a date formatter with the date format string and then pass that into my getJSON function as the date decoding strategy. The result's success associated value is the band struct, so we need to extract the band's results property, which I call albums. I can then step through the albums to extract the album name, which is the collection name, but I only want to print it out if it exists, so I'll use an if-let here to unwrap the optional. Similarly, for each album's release date, I can unwrap the release date with another if-let, and then I can also change up the date formatter's date style and print out the date. When I run the app, you see the results. You can find the completed playground in the GitHub repo. A link is in the description below. So I hope this video has helped you feel more comfortable with fetching and parsing JSON data from an API. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.